Record, Good afternoon, class. I am Adenrele Afolorinso, your facilitator for GSP 103 Computer Fundamentals. This is the second online facilitation. I'm sorry none of you is online right now, but I pray you get to see the video of this class. Today we are going to the module 2 of your course material, and we are going to be discussing computer software. I believe we all know that your computer system is divided into two parts, the hardware and the software. The hardware part is the physical part of the computer system that you see, whereas the software is the programs, the set of programs that are running on your hardware system. You cannot get to see them, but you can get to see their manifestation on the monitor of your system. Your computer hardware also has several parts. You know, the CPU, the central processing unit that does all the processing on your computer, and the peripheral unit. And I believe we all know the peripheral units, such as your input unit, the output unit, and the storage unit. The input units are just the means through which you get your data into your computer, and we have several input units, as you have read in the last module. We have several units, input units. We have your keyboard, which is the most common of all input units. There is no computer right now that does not come with a keyboard, whether it is virtual keyboard or physical keyboard. And you have the mouse and so on. Then you have the output unit, of which your computer monitor is the most common and the most basic of all the input units. I am yet to see a computer system without a monitor through which you see what is going on in your computer. Then you have several other output devices, such as your printer and so on. Now, today we are going to go into the computer software, and we are going to discuss the different kinds of computer software that we have and the role that each type plays in the functioning of your computer system. Like I said before, your computer software is all the set of programs that make the computer system to be active, to make your computer system usable. Without the software, then your physical computer, the hardware components, will be useless. So, what do we mean by a program? A program is a set of codes or instructions that is coded, showing the logical steps that the computer will follow to solve a particular problem and give you a particular result. We have different types of the computer software, and the major classification are in two parts. The first part is what we would refer to as the system software, and the second part are the application software. So what do we mean by system software? As the name implies, the system software drives your system. They are the set of programs without which your computer system would not run. That is, system software are not optional. They are compulsory. In their absence, the computer system will not work. That is the most basic definition of system software that I can give you. Whereas the application software are the optional software that runs on your computer, and you use them for specific purpose. For instance, I'm sure all of you have had one or two interactions with computer If not a full-blown computer, at least you all have your phone, your handset with you, and that is a kind of a mini computer. And you know, when you want to send message to your friends, there is an icon that you will press, and if you are using a smartphone, you tap an icon and a page will open. If you are using the one that is not smart, then you click, you press some buttons on your handset, and the page for SMS will open, and it will allow you to put the name or the contact of the person you want to send SMS to, allow you to type your main message. All those ones are a kind of application software that are running on your phone. It is not compulsory you send SMS with your phone. You might not need your phone for every SMS. You might just need it for just receiving calls. So if you have no need of SMS, of typing messages to people, you might not have that particular one on your phone. Now, to those of us that are using smartphones, you know, you can go to Play Store and download all kinds of apps. All these apps, all these applications, when I say apps, I mean application software. So the shopping form is we shall call them apps. All these apps are optional. Like on my phone now, because I have need to scan documents to people and whatever, I downloaded CS Scanner program on it, and I use it like a scanner to scan documents. I have PDF reader, I have Zender on my phone, but you might not have need. I have my email on my phone. If you are not going to be using your phone for email, you might not download the Gmail or the Yahoo on your phone. So those are optional software that you run. So when we say application software, now if we now go to your computer system, you like your course material, you download the PDF. So when you want to download the PDF, you need a PDF reader, Acrobat or Adobe to read your PDF file. So you will need to download your PDF Adobe on your system in order to access your course material. If it is Word document, you want to type a document like your project, when you get to that stage, you will be needing Microsoft Word or word processing packages like WordPerfect and Co. But if you are not going to be using your computer system, for instance, for word processing, you might not have need to install word processing package on your system. If you need to make presentation with your computer, like when you want to defend your project or seminar or make a presentation, you might need to download the Microsoft PowerPoint or its other equivalent presentation packages on your system. So those ones are optional. It depends on your needs. It depends on what you want to be using your system for. That will determine what and what application packages will run on your system. Now let's go to system software. System software, without it, your system would not run. Your computer would not be able to even run your application software. You will not be able to use your system for anything meaningful. It will just be like a decoration. And there are different classes of the system software. And the most basic of them, the most popular of all the system software you can have is the operating system. You have the operating system, which is the platform on which all other programs run, which is the platform on which all your other processes run, which is the basic thing that controls the use of your system. It is the one that allocates resources to you, the user. When I say you now, I mean you, the user of the computer system, It is the one that allocates resources. You want to use your keyboard, it will allocate it to you. You want to use your printer, it will allocate it to you. You want to use your scanner, it allocates the system resources, especially in a multi-user environment where we have maybe 2 computers, 2 printers to like 15 users. So it is the one that allocates this, maybe 3 or 4 wants to print at the same time. It's the one that will allocate this printer to everybody. So it controls the use of the computer resources. And when we say resources, we mean all the other components of the computer, like your printer, like your scanner, all other gadgets that are attached to your system, including the computer memory. For any program, for any software to run, like your Microsoft Word, for it to run on your computer system, there is need for it to be loaded onto the computer memory. Most of you that you buy smartphone, you go to the store and say, and you will see it will be written there that, oh, this one has a 1 gig RAM, this one has 2 gig RAM. That RAM is shortened form for read access memory. And it is the main memory of the computer that all your programs that you run, your software, your data, anything that the computer wants to work on must first be loaded onto the RAM before the system can run it. So it is this operating system that takes charge of resource allocation to all the users of the computer. And it allocates the memory, the input unit, the output devices, the storage devices, it allocates it to the user. The operating system has several functions. It has several functions, but the basic function of the operating system of a computer is as a resource allocator, like I said. It is to make the computer system usable for the user. Without the operating system, the user will not be able to use the computer system. So that is the most basic of all the functions of the operating system. And based on this primary goal, which is the convenience of the user, the primary goal of the operating system is for the convenience of the user. And based on this primary goal of the operating system, it now performs all other secondary goals like efficient operation of your computer system, making sure that the performance is optimal, making sure that in a multi-user environment that there is no stagnation to any process, that every user has use of desired resources and so on. So that is for the operating system. And the operating system, it has several roles, several functions as itemized in your course material. It takes care of the file management, it takes care of the memory management, it takes care of several other things in the system. And we have different kinds of operating systems. And these different kinds of operating systems, they evolve over the generations. To itemize some of the roles that the operating system will, it facilitates the creation and modification of program. When you want to write a program or you want to edit some data, it is your operating system that makes this possible. It provides access to other system programs like your compiler that translates your programs from high-level languages to the machine language that the system will understand. It is the operating system that provides access to your compilers to translate the program. It provides a loader that will move your compiled program into the computer memory, like I said before, that anything that the computer wants to work on, anything it wants to process must first be loaded into the primary memory of the computer. So it is the operating system that makes it possible for your program, your compiled program, your translated program, your interpreted program to be loaded into the computer memory. It provides routines that handle intricate details of input-output programming, and so on. So we have different types of operating systems, and the operating system came into being in the second generation of computer. The earlier generation, they had no operating system. But in the second generation of computer, the operating system came into being, and over the generation of computers, there has been other types that have evolved. The first one that evolved was the batch operating system, batch processing operating system. There are three types: the batch processing operating system, the time shared operating system, and the real-time operating system. Those are the three major groups. So for the batch operating system, in batch operating system environment, the users will just come, submit their jobs to the central place where the jobs are collected in batch, and the jobs in batches will now be loaded onto the computer memory for execution. And the computer response time, there is something that we call response time. Response time is the time between when you submit your job to the computer for processing and the time that you get the first feedback from the computer. Like now, you are using microcomputers now. When you click that, okay, you want to launch, let's say your Microsoft Word, you click the icon that you want to launch your Microsoft Word. The response time is the time between when you click that icon and the time that there is a sign on your computer that shows that Microsoft Word is loading. That's the response time. So with batch operating system, the computer response time is the turnaround time. What is the turnaround time? The turnaround time is the time between when you submit your job for processing and the time you get the result, the final result. That is the turnaround time. So with batch operating system, the computer response time and the turnaround time was equal, because it is only when the job is completed, that is when, from the time of submission to the time of the execution until completion of the job, that is when you get any response on your job that you have submitted, and that is when you get the result. So for batch operating system, the turnaround time and the response time was equal. And the result will now be given to you after the completion of the job. Then we have the time sharing operating system. As the name implies, it shares the computer time. What it means is that it works in a multi-processing environment, multitasking environment. So there will be several processes that will be loaded into the computer memory at the same time. So it will not share the computer processor and time between all these jobs that have been loaded into the computer memory. So it will now attend to a job maybe for 5 microseconds, then go to another job, another 5 microseconds. So it will now share the time so that no job will stay in the system for too long without response. So this is another mode of delivering computer services. And in this environment, the computer provides computing services to several and many users concurrently. And here the various users are sharing the central processor, the memory, and other resources. And the user in this environment has nearly full interaction, because by the time it is attended to me, it can say, okay, press any key to continue. While I'm doing that, it has gone to another process and it is operating on that one. And so here the response time is shorter. It is no more than a few seconds. The response time is shorter than in the batch operating system, whereby your response time is equal to the turnaround time, which is the time of completion of your job. Then we have the real-time operating system. The real-time operating system are the kind of operating system that you use in time-critical operations, like maybe in the control of your aircraft. They are real-time, we call them the kind of operating system that you use in life-critical systems. They are the operating system that you use in maybe machines that are used to hold the life of a person. Maybe in an operating room where it is the machine that are carrying out, they are the kind of operating system that you use in such environment, such that any failure can lead to death and can lead to disaster of great magnitude. This is the third class of operating system. And they are designed, like I said before, to service those applications where response time is of the essence in order to prevent error, misinterpretation, and even disaster. The system in this case are designed to be not to be interrupted by external signal that require the immediate attention of the computer system. In fact, many computer operating systems are hybrid, and they combine one or two or three of these groups of operating systems. Also, we also have a number of other definitions that are important to gaining an understanding of operating systems. We have the multi-programming operating system, which is the one that is used that allows more than one active user program to be stored in the main memory simultaneously, like my system that I'm using now. On this system, I'm using the Zoom to deliver this lecture. My Word package is open. I have Adobe open. If I were to be sharing my screen with you now, you will see that I have several packages, several application programs that are running concurrently on this system as I'm using it for this online facilitation. So this multi-programming operating system, like your Windows operating system, this later version of Windows, because the Windows 3.0 that first came out was not multi-programming, but like this one, it is a multi-programming environment. Like your DOS operating system, that's this operating system, can only allow one user program at a time. So multi-programming operating system, a good example is your Windows operating system. We also have multiprocessing system, and it is a computer hardware configuration that includes more than one independent processing unit. In a multiprocessing system, you have more than one processor. So the term multiprocessing is generally used to refer to large computer hardware complexes found in major scientific or commercial applications. We also have the networked computing system. As the name implies, it is a collection of physical interconnected computer systems. And we network in order to share resources. Like maybe in our office now, we only have one single printer for like 20 workers. We can now network so that from my system here, I can send data for printing to that printer. You on your table too can send to the same printer. So we network in order to share computer resources and part of computer resources is the hardware peripherals that are connected to your computer, including even the data. The data too is a shareable resources. We also have the distributed computing system, and in the distributed computing system, we have a number of computers and we have a number of users, but the operating system that works in this kind of environment is one that appears to its users as a traditional unit processor system. That is, it appears to the users as if it is the user only that is in that system. Everything is local to the user. The user has his or her own local processor, he has his or her own local memory, and it is as if the user is not aware of other users in the system. And of course, the network operating system, that one allows users to share. So what are the components of the operating system that allows it to do all these several jobs that it does? We have the process management, and a process is just a unit of work in a system. A process is different from a program. A program is comprises of several processes, but a process is just one unit of work in the system. And the operating system, as a process manager, is responsible for the following: creation and deletion of both user and system processes, the suspension and resumption of processes, the provision of mechanism for process synchronization, as in you synchronize the system so that if there is a shared resources, like a database table, like maybe there is a storage where you store the result of your processing, and we are both working on the same storage at the same time. It will do it in such a way that my own update will not cancel your own update to that database object. So it carries out process synchronization, and it makes provision for deadlock handling. It also does memory management by keeping track of which part of the memory are currently being used and by who. It allocates and deallocates memory space as needed to processes, and it does secondary storage management also. And it also does file management. It takes care of creation and deletion of files, creation and deletion of directory, backup for files, and so on. So now to the application. So from the foregoing, you can see that your operating system is the go-between the computer hardware and the user's application programs. That is the main work of the operating system. Apart from the operating system, we have other system software, like your language translator that translates whatever you give to the computer in high-level language, like when we're talking about generation of computers. You have seen that programming languages moved from machine language to assembly language, and from assembly language to user-friendly, programmer-friendly languages that the programmer can just be interacting with the computer as if in a English-like manner. But we all know that the computer is an illiterate that does not understand high-level language. So there is a go-between a language translator, be it a compiler or an assembler or an interpreter that will interpret whatever we have given to the computer in high-level language. It will now interpret it, translate it into low-level languages that the computer can understand, which is the machine language that is coded in zeros and ones. So we have three classes of language translators, and they are the assemblers. The assemblers are basically to translate any program you write in the assembly language that we have earlier discussed, in the assembly language, into machine language for the computer. The interpreters, they work with the high-level languages. Don't forget that the assembly language is still a kind of low-level language like the machine language. The interpreters, they work on the high-level language just like the compilers. The difference now is that the interpreters take your line of instruction. It takes your instruction statement by statement, line by line. It takes it statement by statement, line by line, and execute it. It translates it and executes it and gives you feedback. And until, if there is an error on any line, it gives you feedback that there is an error, and until you correct it, it does not go ahead to execute the other lines or statements after that error statement. But the compiler on the other hand, takes your, let's say you have written like 1,000 lines or 1,000 statements of instruction for the computer to execute. Your compiler will take it as a whole. It will translate it and generate object code for it. It will generate an executable file, an executable document that can be loaded into the computer memory for execution. If there is now an error, when you are now running the program, it will now give you, after translating the whole thing as a whole, it will now be giving you error in line so there is this, in line so there is this, in line so there is this. Whereas the interpreter translates and executes your code line by line and gives you feedback immediately, and until you correct the error on a line, it does not go to execute the next line after. That's the difference. And when we are talking about compiler, there are different stages of compilation. We have the lexical analysis, we have the syntax analysis, and we have the semantic analysis and the code generation. So we have talked about language translators, which are other types of system software. Now we have the utility software. The utility software are the set of commonly used programs in data processing departments, and they are generally called general purpose programs. And they carry out such operations such as file conversion, like data transfer from one medium to the other, making an exact copy or editing or validating on a storage medium. Then it also takes care of file copy when you copy a file from one medium to the other. It also takes care of housekeeping operations, which include programs to clear areas of storage, writing file labels, and updating common data. So we call this housekeeping operation. So with that, and another class of your system software are your hardware drivers. Your hardware drivers, like in those days, when you buy a printer, it will come with an installation disk, and you have to put that disk into your system and install it before your system can see that printer. But these days, we have made everything plug and play, that even if it does not come with an installation disk, you can easily go and then even do backward engineering so that the system that they make today will be able to use earlier hardware. So it will see it automatically, or you go online and just download the software, the driver for that hardware. So every peripheral has its own, apart from your mouse and your keyboard that they made plug and play. Other ones, they have their drivers that will first be installed onto your system before your system can see those hardware devices. So we now go to application software. Like I have said earlier, they are just the set of programs designed to solve specific problems for you. Like you need to do some basic addition, subtraction, accounting, or whatever. You can use your Microsoft Excel. You need to make a presentation, you can use your Microsoft PowerPoint. You need to type a letter, you can use your Microsoft Word package. These are application software. There are some that use a PageMaker, CorelDRAW, make graphics. So, which means they are optional on your computer system. And this application software that we are talking about, there are two types also. We have the generalized, that we can call the off-shelf packages, and we have the user-defined software. What is the user-defined application software now to be specific? Where lies the difference? The difference is There are some generalized ones that has been made for general purpose, for general use, as in you want to do word processing. Then there's Microsoft Word there for you. You just go, you buy it, you call it off the shelf, you just go to the store, you buy it. I need a word processing package, you buy it, you install it on your computer, and you are good to go. And anybody can buy and use them. But now there is a particular thing that I'm doing in my office that is routine, and I need a software that will be able to do it for me. Then, in such a case, I must be talking to a programmer if I'm not a programmer myself, and I'll tell the programmer my specification, my requirements, I need this, I need it, and the programmer will now develop a software to satisfy that need for me. That is what we call user-defined application programs. They are customized application programs that are developed to satisfy a particular need for a particular user. They are not generalized software like your desktop publishing software that you can just buy your CorelDRAW, your Ventura, or your spreadsheet accounting, whatever. You can use your 123, use your Microsoft Excel, and so on. So now, if we are talking, what are the examples of generalized application software? We'll be talking about your Microsoft Office or Microsoft Word, Microsoft PowerPoint, and so on. If we are talking about user-defined application software, then you will be talking about a program that I wrote to do something on my system, or somebody developed for me to do something on my system. It's not something that you can just go out and go and back. So it might even be platform specific, because it might be written based on the kind of system I am using. So it might not be able to run on other kinds of systems. It might be developed for instance, for microcomputers. That means you cannot take it to a mainframe computer and expect that it will work. It might be developed to work in a Windows environment. It means that if you are using a Linux operating system, it will not work on it because they are customized. It is just like a cloth that is sewn for me. Except we have the same build and we have the same taste, you cannot wear a cloth that's sewn for me. But we have ready-made cloths that you only get there, and they said it is free size. It is free size, it is unisex. So that one can be likened to your generalized off-the-shelf application system like from Microsoft Office, Microsoft Word, and co. So with that, I believe I have covered computer software. In a subsequent lecture, we'll be discussing the various computer languages and the various programming languages, how to develop programs, and so on. It is unfortunate that we were not physically present during this online classroom to throw your questions, to make it more interactive. But I hope when you get to see this on your menu, you will listen to it, watch it, and then come up with questions that you can ask me during the next class. The next class is going to be April 9 of 2019 by 3 p.m. prompt. and I hope see you then. I hope you will be here to participate in the class, and I hope you have been going through, even though I might have a topic I want to discuss then, that does not preclude the fact that having gone through your course materials, you can pen down your questions, you can pen down the topics you want us to discuss in this next class. Your needs is the priority here. It is not whatever I have prepared to discuss. It is whatever your need is that will be addressed. So if you have questions, if you have topics related to this course that you want us to discuss, you can let me know before the next class or during the next class. Raise it and we'll trash them together. I remain Adenrila Solonshaw and the facilitator for GSP 103. Bye bye. See ya next class. Remember.